Okay, here we are talking more about exponents. We've learned some exponents in class, and I'd like to go over some of the other properties that we're going to need to know for CP Algebra 1. Here is a recap of everything we've done so far. We've got the product of powers, quotient of powers, power of a power, power of a product, power of a quotient, definition of to the zero power, and definition of a negative exponent. I'm not going to go over these now. You have them in your notes, so if you need to just refer back to them, you can. But these are the rules with their, these are the rules. So let's move on. And I want to ask you, if we know that a to the negative second power, for example, is 1 over a squared, it is the reciprocal of the positive power. What do you think 4 times a to the negative second power is? How would we simplify that? I want to remind you that we've got invisible multiplication here, in between the 4 and the a to the negative second power. And exponents can only whisper. You can only talk to the thing that's right in front of you. So this exponent cannot whisper or cannot shout beyond this multiplication symbol. Remember, exponents comes before multiplication in order of operations. So if that's the case, this exponent, this negative exponent, is only talking to the a. The 4 is a 4, and it is being multiplied with 1 over a squared. I would then simplify that by multiplying basically a fraction with a fraction, and I would have 4 over a squared. So the purpose of this is to review which number or variable has a negative exponent talking to it, and what do I do with everything that's left over. It will just stay where it is. So on here, we're just ramping it up a little bit more. The 4 has no negative exponent, it's not going to stay. A to the negative second power, that's going to go downstairs then, isn't it? B to the third power, the 3 is not negative. It's not being told to move anywhere, so he will stay upstairs in fraction land. So we're going to have the 4. I'll write over 1 now, but I wouldn't normally. But I'm just showing you all of the steps to create that simplified expression. This will become 1 over a squared, and b cubed will remain where it is. And now we're just going to go multiply through the tops and multiply through the bottoms. So as a numerator, I'll have 4b cubed and a denominator over a squared. Did I mention I need you to write these down as notes? Let me tell you now, these are your notes that I would like you to copy. Or you wait until we get to the end of this kind of thingy and you take a snapshot of it or something like that. Maybe you can do that watching the video. Okay? So let's look at this one. I notice I've got some with no exponents, probably the invisible one, some negative, some positive, oh, another negative. So this time, I'm not going to write out each step. I'm going to think about it as I go along. And upstairs I have 4b cubed. They have received no instructions to move downstairs. Downstairs, because I have the reciprocal of this, a squared goes downstairs, c to the negative first goes downstairs. And they show up as their positive version. And if we have a power of 1, it's invisible. It can't be invisible if it's negative 1, because then you're missing its meaning. But it will be invisible if it's regular 1. And the last one, very similar things. I was just making it a little more difficult as we went along. So I've got 4 upstairs, that's downstairs, upstairs, downstairs. Oh, to the 0 power, do we remember what to the 0 power means? It means it equals 1. And in multiplication, 1 is invisible. So this variable, if in effect, disappears. So this is our answer. Now you can put me on pause at any time you want so that you can copy this down, but I'm going to move on to board 3 of 5, so you know where we are in the sequence of things. We're on board 3 of 5. So another question. Again, if a to the negative second power is 1 over a squared, what does 1 over a negative exponent mean? We have 1 over a to the negative second power. Well, I know that this Here's the 1 on top. This is 1 over a squared. Is that correct from the previous board? Well, I cannot have a fraction within a fraction. And I'm going to ask you to think back to the days of dividing by fractions. Isn't dividing by a fraction the same as multiplying by its reciprocal? You recall that? I hope so. So in that case, this 1 is not being divided by this fraction. We're going to call it as this one here, being multiplied by the reciprocal. So we have 1 times a squared. The answer is a squared. Now you need to let that kind of digest and sink in. If the negative exponent is under the fraction bar, it's going to reappear above the fraction bar in the positive version. Just like if it was above the invisible fraction bar here, it goes below as a positive version. Here, it starts below and goes above. So it's a nice kind of little flip-flopping going on, isn't it? So this one here, I've learned that if it's negative below the fraction bar, I'm going to send it upstairs as a positive version. And it's just going to be multiplied with the 1. And that's going to disappear in a minute, isn't it? And that's equal 1 times 25, which is 25. Okay? Here, similar. Negative downstairs shows up upstairs. Just going to write it like that. We've got the hang of it now. This one we have a numerator other than 1. Recall up here the numerator is multiplying with what's coming up from downstairs. So I do need to multiply this 3 with this x to the 4th, which has come up from downstairs. And that's just equal to 3x to the 4th. We'll move on to this one. We've got a numerator upstairs. We've got some kind of coefficient, or maybe we just call it a number downstairs. Remember, exponents only whisper. This negative 2 is only applying to the y, not to the 5. So my 3 stays upstairs, my 5 stays downstairs, and my y to the second, the negative second, takes a trip upstairs with the positive exponent. I'm going to continue, and then you're going to look at this and let it all sink in. So, what have we got going on? 4, not moving. This y to the negative second, upstairs, he's going to go down. The x to the negative 4th is going to go up. And this 5 to the negative first power, he has to go upstairs too. So we've got a lot of movement going on. The 4 stayed where it was, but I'm going to multiply it with the 5 that's moving. I've got the x to the 4th that's going up, and I've got the y to the second that's going down. Now let's just make sure we've simplified it as much as we can. 4 times 5 is 20. X to the 4th over y squared. So take a minute, put me on pause, and let that all digest and copy it down. I'm moving on. And the last one. Well, not quite the last one, but the last kind of rule thing. So we learned that the power of a quotient was equal to the power of the numerator and the denominator. We could apply it to both the top and the bottom. We only worked with positive values in class. So now I want us to talk about, but what if it was a negative exponent with a fraction? What's that going to mean for us? Well, hold on to your horses. Negative exponent under the fraction bar. 1 over a over b to the nth power. So what we've done so far is got rid of the negative exponent. I'm now going to apply the exponent 1 over a to the m over b to the m. But like I said before, we cannot keep a fraction in a fraction. So we're here trying to divide by this. Well, we're going to turn that into multiply by the reciprocal. What's the reciprocal of a to the m over b to the m? It is flipped, b to the m over a to the m. So this is going to be 1, the numerator, multiplied with the reciprocal of our fraction. And when we multiply by 1, it disappears. So I'm just going to, because I really don't have a lot of room, I'm going to get rid of it. And there is our answer. How cute is that? So if we have a fraction to a negative exponent, manipulating it through these stages, you will find that our fraction will flip upside down and the power will be applied to both of them as the positive version. So let's do it with this one first. And my suggestion, how I would do it is this. I'm going to first of all flip the fraction and use the positive power. That, I think, for me is the easiest way of doing this. If I see a negative power with a fraction, flip it, change the power to positive, and now apply the exponent. 4 squared is 16, 3 squared is 9. So, my suggestion to you is flip the fraction, use the positive power. Now apply it. I've got to apply it to the top and the bottom. So I'm going to have y cubed over 3 cubed is 27, x cubed. Tricky one here, look at this. I'm going to flip it. And then apply it. And I'm using virtually, well not quite, but nearly all of the rules we've learned so far here. Apply it to the top, z to the 6th, over 4 squared is 16, x squared to the 2nd power is x to the 4th, y to the 2nd power is y to the 2nd power. Wow, that is a lot to digest, but I wanted to get all of the rest of our rules on one tape. Put it on pause, copy it down, think about it. And the last board is just a practice board, and I just need to slide that across. It's practice for everything we've just done. So I'd like you to copy down all of the practice ones, and it's just simplify. So I gave an example, simplify completely, use all of the known rules you have and definitions. I've given an example here that you can look at. Copy these 9 down and simplify them to the extent that you can using properties and definitions. Okay, thanks.